Hey everybody, how's it going? I've been in Japan, so I've not been doing Leetcode. So let's take a look here. Leetcode 2536. I have not done this before. Increment submatrices by 1. You're given a positive integer n, indicating that we initially have an n by n, 0 indexed integer matrix mate, I guess, filled with zeros. Oh, interesting. You're given a two-dimensional integer array query for each query I equals row 1. You should do the following operation. Add 1 to every element in the submatrix with the top left corner and the bottom right corner. That is... Alright, and query's length is 10 times to the 4th, and there's 2,500 cells, so you have an n squared, so you can't brute force it. Got it. Return the matrix after performing each query. Now, I think we could do 10 to the 4th. No, excuse me. 500 times, right? I think so. I think that's how we'll do it. Okay, so... we're going to have heaps and heaps like this times n, right? No, that won't work. For I in range n, there we go. And so that'll be like the row. Okay, and then we're going to say for... I don't want to type this. In queries, is this going to work? Print row 1I. All right, seems to be working. So, okay. So for each of these, are we calling the row or the column the first one? Well, that's probably important, isn't it? So for row in range, column 2I plus 1. Yeah, so it's going to be hs.heap insert, heap push, I guess. And it's not a class. Oh, that was bad. Okay. Yeah, so we're going to start adding here. So column 1I, 1, right? And then column 2, negative. So we want to stop adding, I think. Okay, then we should be able to construct every one of the rows. So R is going to be return value. And we're going to say for heap in HS. And then for I in what? Well, in range n, of course. Yeah, and S is going to be the sum. So, oh, wait. And let's have each of these just have like some ridiculously large thing, like 5,000 zero or something, just so that we know. I don't know, that was not 5,000, but you know what I mean. That way I don't have to check to make sure that it's actually populated. It'll always be populated. So while H of 0 is lesser than or equal to I, then we are going to, we don't actually care what the number is, we just care about the delta, the increment, the I can't reuse I, is heap pop H heap pop H, like that. So, is this really inefficient? Let's not do it like this. I think converting the tuple into something that you can extract numbers from is inefficient. So if it's less than I comma, I don't know, -2 or something, lesser than or equal to. No. It'd have to be I and then something bigger, right? Yeah, I almost did something stupid there. So S plus equals delta, and then R dot append, boom, and then R -1 dot append S. And I think that should construct it row by row. Now the question is it going to be too slow? I guess we will see. 1 1 0 1 2 1 0 1. Oh my God! Well, it should never be negative, that's for sure. Okay, column 2 is always bigger than column 1, right? Smallest goes first by default in a heap, unless you use a custom sort order, right? So heap pop like this. That was a silly mistake. Oh! Cool, it's working. Did I print anything? No, let's see if it's fast enough. Oh, that is taking a while. I have a fear. Oh, I hate you so much. Think there's some way to optimize it? I mean, probably. I guess if you had adjacent values, you could combine the numbers, but you would have to know that they were adjacent. This is quite annoying. Can I expand this to be two-dimensional? Thinking. Obviously, the problem is right here. That's going to create a lot of information that gets pushed into those. Thinking. What if you had like a special... No, because if you had a special mechanism, then it would just be like over and over again. That's not going to work. Is my entire technique flawed? No, because let's say that I could get a lookup down to log n. There's still 10 to the fourth queries times 2,500 times log n. That's not that bad, actually. Ultimately, that is kind of what I have to do. I'm at a loss here. Yep. Now, if I have to query these one at a time, this isn't going to work. I might have to look at a solution. I don't. It's just not clicking. I mean, in my defense, I've been a little sick, so maybe that's the problem. Yeah, I have nothing. This is frustrating. Brute force, huh? (2D difference array solution). What if you could have a separate row and column modifier? Ah, you're talking crazy now. What if we knew the max amount that could be added and we started from a negative number? That is so stupid. Iterate over queries, start from row to end row, add one to the start column. So far it sounds exactly like what I did. Add -1 to the next column. I even did the sum the same way. Row-wise prefix sum. Oh. That is brilliant. Well, now I hate myself for not thinking of it. And of course, the built-in method is going to be faster. Let's just call this R. 0 for I in range, N for J in range, N. So we're basically doing the same thing, but we're not doing any of the heapable BS. Is it really that much faster? Well, I guess we're going to see. So R of, I can't have it both be called R, that doesn't work. Ret of R of row 1I plus equals 1, right. And then ret R of row L2I minus equals 1. Not row, column. These are going to be too long. Not necessarily. Let's do it this way. if right? Okay, and then just return list of accumulate of I for I in ret. Invalid syntax. Did you perhaps mean to include a comma? For I in range n, for j in range n. What am I missing? That looks fine to me. Did I like do something stupid like parenthesis mismatch or something? I for all right, let's see if that passes. All right, cool. I mean, it's not great, but I got it, so that's what's important. See ya.